Welcome back to my channel Conquer the Fear. In this video, we are going to discuss about top 5 message broker based interview questions, which are Kafka or RabbitMQ related questions. So let's begin the video. So if you are attending any interview which are related to Java, Springboot or microservices, you will be definitely asked about this particular interview questions, and you will find one of this particular interview questions definitely in those interviews. So the very first thing is, what is message broker? Now what problem do they solve in distributed system? Now for a reason this particular system are introduced, you must be already working with a different message broker, but I would like to tell you, what exactly the message broker is if you are not aware. So message broker is nothing but it's an intermediate system which is act as an independent applications, where your applications or a services or a microservice communications going to communicate with each other. Okay, so either by sending or receiving the message, they will communicate with each other. So it is going to be a central location or a central hub where the sender sends the messages, which is called the producer, or the receiver is going to receive the message, which is called a consumer. Okay, so these are reliably going to depend on this particular central hub system, and it is going to be an asynchronous message delivery. Now, what problem do this particular message broker or like this particular they solve, right? The distributed systems. The very first thing is that the decoupling and the asynchronous communication. Now, when you are dealing with a REST API, or when you're dealing with the problem of direct synchronous communication, now there are many services which are going to be very tightly coupled. Okay, and which is going to have a bottleneck over there. Now, let's say one service fails down, the other services will definitely will fail down. Okay, so in order to solve this, the producer is going to send the message to this particular broker, and the consumer, without knowingly who sent this particular message, is going to consume it. Okay, the consumer is going to retrieve it when it is going to be ready. So this is going to be a very independent operation, and it's going to work on their own pace. Okay, now the second thing is reliable delivery and durability. Now let's say the message which was sent, okay, let's say the service crash or a network failure happens. Okay, so the direct communication, there will be a failure over there. So what happens is that this message broker is going to store the message until this particular messages are successfully consumed by the processor, the consumer. So they are going to be persisted and stored in the messaging system until it is started, or it is until purposely removed it. Then comes scalability and the load balancing. So basically, let's say you have a single service. Okay, so now it has got overwhelming request, right? A very high volume of request. Now what happens, the system will slow down, right? Now the solution to this is that there is a multiple consumer which can be configured up. Okay, you can subscribe to the same message queue. Okay, which is going to allow parallel consuming, processing, and then distributing the workload. Okay, so the brokers can also support message routing to a specific consumer also, but yeah, that can be a configuration to be done. Fault tolerance and resilience. Now this is very quite important, because when the failure of one service can also lead to a cascading effect, and it can impact the entire application or entire system. Okay, so if one consumer fails, the message remains on that particular broker, and the another consumer can pick up whenever it is required. So this is going to be a system which is going to be very robust and resilient to a particular component failure which occurred. Okay, so integrating with the disparate system. Now when you're integrating a system which is built on with different technologies or languages, it can be quite complex. Now the solution to this is that broker is going to provide you a standardized communication, a standardized protocol, so allowing you to diverse your system to an exchange the data format without having dependencies or a direct dependencies on it, right? So that's where how it solves it. I hope you are able to understand the first question. Second, explain the core concept of asynchronous communication. Now, there are three things when you are dealing with asynchronous, as I mentioned. One is producer, one is consumer, and one is the topic or a queue. Okay, so you must be knowing what asynchronous communication is about, where the system is not going to wait like the REST component, right? Where it requires an immediate response, right? Now you are in this particular asynchronous communication, there will be nothing being waiting, there will be no immediate response. Okay, So instead they will send the message, they will stop, and then they will continue their own work without waiting for the response. Now what happens with that is that let's discuss one by one. One is producer, right? So what exactly is in producer? So it's an kind of an application or a service that is going to create and send the messages to it. Okay, now what action it is going to do? It is going to produce the messages and it is send it to the broker, or like it is subscribed to some of the queue or a topic, right, directly. Now what happens is that the main purpose is that it is not going to wait for it to be processed. There has to be no reply to be received. So it is just, it does the work, it sends the message, and their part is done. Okay, and it is goes to the next job of part. Now example, let's say you want to write or drop a letter into a mailbox. You doesn't have to wait that. This is a real example of that, right? So recipient is not going to wait for the recipient to read it until, right? Its just purpose is that it will just drop the message and go. Then comes the consumer, the other part, which is going to be the application which is going to receive your or send messages, right? So it is going to consume the messages. It is from the broker. Okay, so there is a common hub it is going to take the message from. Now let's say if you pick up that particular message whenever it is particularly fully ready, and then only you process it. Okay, so that might be you might send a reply to it if it is necessary, or if it is not necessary, it is going to be directly. So there is no direct immediate response has to be sent up or to the producer, right? So it is an independent system. So someone, let's say an example, someone is going to check their mailbox, it is going to pick up what letter it has come to him, and then it is going to read it. That's it, like that's the job of it. Now the intermediate system which I told you, right, which plays between the consumer and the producer, is a topic or a queue. Okay, so this is something where the messages are stored first, and from there this particular delivery mechanism, either message consumer picks up, or it is temporarily stored, right? So there are two things, one is queue and one is topic. So they both are used in a different context. The queue is called point to point because a message sent to that particular typically is processed only by a single consumer. Okay, now let's say the use cases are like, let's say you want to distribute something or a task distribution, right? Let's say you want to send an email, you want to process an image, where each task has to be done once in a lifetime, right? So that kind of scenario we have to use it. So let's say you have a to-do list, okay, which is you are sharing among your workers. So that's a one time task which you want your workers to be picked up and to complete it. Now then comes the topic, that is the public subscribe model. Now this is going to be a topic which is going to receive a multiple consumer, okay, by the multiple consumer. So let's say you wanted to broadcast something, like let's say you have a TV, right? So, or a channel, right, which is been broadcast by a single person, but it is been watched by multiple people, right? So, or a stock price updates or system alert, right? Anything where many people are interested for the same kind of messages, or a news basically. So news channel, if you see, right, it is going to publish a notice to everybody. So everybody is going to read the same message at the same time, or maybe at their own convenient time. Now, when do we want would you choose the message broker and instead of REST API, right? When you are dealing with the inter-service communication. So what is the ideal choice, or when do you choose it, right? Now when you are dealing with message broker, it has got a very advantages over the direct REST calls what we do, right, when you are dealing with the inter-service communication, and especially when in the distributed system. So what you do is that there are certain characteristics which are required for it. Okay, we'll discuss one by one. Now let's say you want your application to be having a synchronous communication. So you must be already knowing REST has got the limitation, and it is a synchronous communication. The client has to make or wait for that particular response, right? So the server is, let's say on the server side it is busy, or that it fails to respond it, the client will be ever waiting, it will be blocked up, and it will be immediately failing the system. Okay, so that's where the message broker comes into the picture. It is going to send the message onto the broker, and it doesn't have to wait there, and it is simply going to process it later when its own time and its own pace. Okay, so this is very an ideal situation where you send out the notification and leave it, that's it. Okay, so the other one is going to handle it. So this is going to be a better way to hand the responsiveness of the calling services, right? Now let's say the other example is when you need some decoupling or the loose coupling things, right? Now REST is directly tightly coupled. Okay, so when you're calling some services, there is a network location where you require, there is an API contract which is where the service is getting called up. So any changes in the server, then there will be impact on the calling services. So it is tightly it is tightly coupled, I would say. So the message broker is nothing like that. It is going to communicate to the broker, and it is not going to deal it with directly. So the only way you can do is that you have to send the message to the broker address, and from there the next set of actions will be taken on. So you are not dealing with anything or anything which is there. So you have to physically deal with, right? So this is going to be an independent way, the deployment, and you can scale it up for the things. Now, the another scenario is when you need high reliability and a guaranteed delivery. Now, let's say you are dealing with REST, right? If you are receiving a message, or let's say there's a service is down, the network is occurring some congestion or like REST calls, right? Then the request might fail. Okay, so the message will lost, and unless the client implement certain complex retry logic, it is not going to be retried, right? So that's where the broker comes in picture. Like it is going to persist that particular message on that particular disk, and if the consumer is down, the message will still remain in that particular broker until that particular consumer is going to recover and it is going to process that message. So these are the features which is going to save your time, save your application, and will give you a high reliability and a guaranteed delivery. Okay. Now the another scenario is when you need some scale independently, you want to handle some burst of the traffic which has come uncertain, right? So now you already know the rest has got some limitation, which your service is going to experience sudden spike in the request, then it is going to be overwhelmed, it is not able to handle, it will be definitely slowing that particular system, and it might lead to a permanent failure as well. Okay, so scaling is very difficult in comes to synchronous process. So you have to handle it by carefully having the load balance, or you have to write your own complex logic over there, and some retry mechanism has to be handled over there. But when it comes to message broker, you have to deal with that in a better way. So there will be, at the peak of this particular load as well, this message queues are designed in such way that it can scale right independently. There will be a configuration which you can configure, like multiple consumers can consume that particular message, right? So the same topic in the parallel, so it is going to effectively load balance the workload over there. So this is going to act as a buffer. It is going to prevent you from sudden traffic spike from which the overwhelming downstream service is behaving, right? Let's say the another scenario is when you need to implement certain complex communication patterns. Let's say you want to implement a publish subscribe model. Now, REST is primarily a point-to-point or a communication, which is a synchronous communication. So it is going to react to a certain event. So we have to make sure that we have to make a multiple calls. That is going to be a leading to a boilerplate code, and it is very tightly coupled. So message broker is where it is going to support different patterns. Okay. So let's say one of them is subscriber model, public subscriber model. So one producer and sends a message to the topic, and there can be multiple consumer which can going to be subscribed to that particular topic, and then it's going to receive the message. So this is one of the perfect example where certain event is broadcaster and other peoples are waiting for the next set of action to be taken up. So the multiple consumer can complete that particular own processing task with the single messages which has been acted upon that. Now when you are dealing with a disparate system, right, when you want to integrate with a disparate system, so REST is going to definitely you can integrate with the different technologies and the languages, but it is going to be having writing through a custom adapter for each of this particular connection what you are doing. But message broker doesn't work like that. It is going to behave in a common technological communication interface. So as long as that particular system is going to connect to that particular broker, its work is done, and it is going to be dealing that particular message format and other things. It will be taken care over that. So they can communicate regardless of that particular internal tech stack or their own logic. Now, the next question is, how does Kafka achieve high throughput and fault tolerance? Now, Kafka is known for this particular thing where you must have already heard of, like in multiple interviews, like how this particular throughput is achieved, how to the fault tolerance can be achieved. So indirectly they are asking about Kafka's main features, how do they do that, right? Now we'll discuss. The first thing is high throughput. Now if you have heard of the Kafka, right, there is a concept of partitioning. Now topics are divided into a different partition, so they are independent and they have some ordered logs. Okay, so this is going to allow you to do some parallel producer consuming, right? If the multiple brokers are there, multiple consumer instances are there, so partition is equal, the more the partition are there, there will be a more concurrency being achieved over there. Now next comes is the sequence of IO. Now messages are appended sequentially to an end of that particular log file or a disk, right? So sequential writes are significantly very fast than the random write whatever we write, right? So that's what the benefit. Batch processing, now when you're producing certain messages or a group of messages, multiple messages in the batch, right? So before sending them to the broker, right, so we have to use that particular thing. The broker can write this particular batch to a disk, so this can also reduce your network overhead or a disk operation per that particular message. Now there is a zero copy principle. Now Kafka is going to use an operating system. There is a called a send file system called, which is going to be a direct transfer the data from the disk to a page cache. So in the network socket, I would say. So this is what exactly happens is that there is an unnecessary. It is going to avoid that unnecessary data copying between this particular kernel and the user space. So there is a lot of reduction in CPU cycle, memory usage, and the bandwidth whatever it is going to consume. Now Kafka is called for decoupling the consumer. So consumer is going to independently handle their own rate of offsets, right? So this means the Kafka don't, is going to track that particular thing. So which is the message has been consumed by whom or not, the reducing the broker overhead over here. So this is been taken care over there. Let's discuss about the fault tolerance. Now the very first thing is replication factor. Now each partition what we discussed earlier in the topic is going to have a replication where across the multiple brokers. So let's say if one of the broker fails, right, there will be another broker which is going to hold that particular same set of data, and it is going to ensure that the data is available throughout. There is a leader follower model. So one partition, one replica is designed as a leader, so it is going to handle all your reads, all your writes. So the other replicas which are the follower is going to very passively write that particular data from the leader. Now in sync replica, now only followers are fully caught up with the leaders as considered, right? So it has to be very in sync up with the leaders. So when the leader is going to fail, the new leader will be coming from the in sync replica, right? So it is going to pick up from there, so there is a no data loss, so there is always a data which is going to be there, right? So there will be no failover. Now there is a producer acknowledgement. The producer is going to configure, like, whether this particular how many replica must confirm or write before it is going to consider the successful message has been sent out, right? So there is an acknowledgement. So when it comes to zero, right, it is called the no acknowledgement, so high throughput and low durability. When it comes to one, the leader acknowledges that there is a good balance between them. Okay, acknowledge all. Now there is either equal to -1 or all, right? So in sync replica is going to acknowledge there is, like, there is a thing. So in this particular there will be all this particular message are returned to certain disk. Okay, so all the combined replication is going to ensure that there is a durability of the data, and if there is an, let's say, a crash in the system, there will be an entire system will be ensuring there is a data will be available. Okay, explain the consumer group and how they are enabling the scalable messages consumption. Now, when you're dealing with this particular consumer group, right, we already discussed about producer, consumer topic, right? Now, what is this consumer? So this is called the group of consumers, which are, like, either one or more of them, which is going to consume the instances that are going to communicate the messages from one of the particular topic, right? So the what is the purpose of it? Now it is going to use for the parallel processing. It is used for the fault tolerant processing of the messages from the topic. Okay, now how it works internally, how to scale it, right? It is there is a shared responsibility. Now all consumer is going to consume from the group of, collectively there is going to share their responsibilities of reading their own messages from the topic. Now there is a unique partition assignment. Particularly, each partition within the topic is going to assign only one consumer instance to the specific consumer group at a given time. Let's say if you have a topic of three partitions, okay, let's say P0, 1 and 2. Now you have two consumers, right, C1 and C2 in the same group. Now C1 might get P1 0 and 1. Now C2 might get P2. That's why how the distribution happens, right? Parallel processing, since different partitions can be processed by the different consumers in instances concurrently, the consumer group is going to allow for a parallel consumer. Now you can add more consumer to the group, its number of the partition, right? But it can increase the processing capacity. You can increase the scalability. So there is an horizontal scaling which you can do. Let's say you to scale up some message processing system, you can simply add some more consumers, okay, to the instances of the group. So consumer automatically rebalances your partition assignment. There is a limited by partition. So maximum number of active consumer in the group can be effectively consumed from the topic, which is going to be limited to the number of partition in that particular topic. So you have to be more consumer than the partition, right? So some consumer will be definitely be idle over there. Fault tolerance within the same group. Now let's say if you consume instances in a group fails, right? Consumer is going to detect which particular like it is got there is a technique called heartbeats, right? It is going to detect that. Now it is going to reassign that particular partition that has failed, right, by the consumer, which was handling by the other active consumers in the same group. So this is ensuring that the processing is not stopped, and there is a manual, there is no manual things has to be done over there. I hope you are able to understand these particular questions, what kind of practical and scenario based questions are asked with respect to the message broker. And if these particular questions are asked, you are going to definitely answer this. I hope I was able to explain you properly and make you all understand what kind of interview questions are asked with respect to the message broker. If this video was very helpful, please share it with the needy people. Also, don't forget to like, subscribe and hit the bell icon. Thank you for watching.